Here's Precalc. It's problem 8-80. It wants you to find the angle in between these two vectors. And honestly, the first thing I did when I saw this question is I wanted to draw, I forgot that I had a formula for it, and I wanted to draw the vectors. So I went left 6, up 3, and I actually found the magnitude also, because I went 6 squared plus 3 squared equals c squared, and that number right there is the magnitude. But anyway, I did that, and then I did right 2, up 4, and I, for some reason, thought it would be good to find the magnitude, so I did 2 squared plus 4 squared equals c squared, and that's where that 2 root 5, that's the magnitude. And then I could have, and then I looked at it and I thought, well, I guess I could just use SOHCAHTOAs on it actually, you know, because I've got side lengths and right angles, and I could find this angle, and then I could go this angle plus this angle equals 180. But then I was like, no, because I know that we have a formula for this. And actually, let me share that formula with you so that you don't have to do it that's a pretty long way to do these problems. So here is page 268, and the formula to get the angle between two vectors is the dot product. And so this, on page 268, it kind of explains if you have your vectors in component form, then first you're going to u dot v, which means you're going to go you're going to take, I don't know, the two first vectors and multiply them together, and then to that you're going to add, you know, u2 times v2, and that gives you a dot product. And it gives you a little example. And then if you use this formula, you could just say, well, cosine theta, or that, whatever u dot v is, like whatever you get here, that's equal to the magnitude of u times the magnitude of v times cosine theta. Well, what I did is I solved this for cosine theta by dividing both sides by the magnitude of u and v, so that I can, because I'm interested, that what I usually use this formula for is actually finding the angle between some vectors when I can remember to do that. So I have this, I have this written in my magic book, so I'm just going to use that from now on. So here's my magic book. And this is the same formula that you just saw in your textbook on the math notes box, but all I did is I divided both sides by the magnitude of A times magnitude of B, so that it's nice and neat and tidy for me. And now I'm just going to follow this using these two vectors. So it tells me that on the top I have to do A dot B. So I'm going to dot these. Like I'm going to go negative 6 times 2 is negative 12. 3 times 4, that's positive 12. And then I'm going to divide that by the magnitude of A times the magnitude of B. Well, I already had, remember, luckily I already had those. And those came from Pythagorean theorem, like a squared plus b squared equals c squared. So I already had those, so it's 3 root 5 and 2 root 5. But I really didn't need to find those because negative 12 plus positive 12 is 0. And 0, if that ends up being 30, 0 over 30 is still 0. So now, according to this, cosine theta is going to be the dot product over, or it's going to be basically 0 over 30. So cosine theta is 0. So if I inverse cosine both sides, I'd have the inverse cosine of 0, which is 90. I did not have to use my calculator for that because I know that this is cosine, right? And that's sine. I know on my unit circle that cosine is 0 at 90 degrees. So that's the answer for letter A. Letter B, they try to throw a little monkey wrench in there. They give you the IJ form, but I just turn it right into component form. This one was interesting because it just said negative 2J. That means that there was a 0I, so that's a 0, negative 2. I didn't bother drawing it because I just want to use my dot product formula now. So I'm going to dot 3 times 0 is 3, and 4 times negative 2 is a negative 8, and then I'm going to get the magnitude. See how it says magnitude A times magnitude B? So the magnitude of this first one is 3 squared plus 4 squared is C squared. I just recognize that that's going to be 5 because it's a 3, 4, 5 triangle. And this would be 0 squared plus negative 2 squared. Well, that's going to end up being 4 is C squared, so C is 2. And then 0 plus negative 8 is negative 8. So I got negative 8 tenths, which is negative 4 fifths. And so cosine of theta is negative 4 fifths. So then I want a cosine inverse negative 4 fifths, and I got 143.13 degrees. So that's the angle between these two vectors. If you wanted to draw the vectors, you could look at them. That's all I got.